Welcome to PreMath. In this video, we have got this yellow shaded triangle AFB fully confined in a blue rectangle ABCD, as you can see in this given diagram, such that this EF is the perpendicular on this side CD, and moreover this segment DE is 4 units, whereas this segment EC is 5 units. And now our task is to calculate the area of this yellow shaded triangle AFB. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let me go ahead and label this segment AF as our X units. And we are going to label this other side FB as Y units. And now, since we are interested in calculating the area of this yellow shaded triangle, and now let's recall the area of a triangle formula. Area is always equal to a half times base times the height. And we can see for this yellow shaded triangle, this side is our base and this side is the height of this yellow triangle. So therefore, now our task is to find the value of X and the value of Y as well before we could calculate the area of this yellow shaded triangle. And in this next step, I have extended this perpendicular EF all the way to this point P. So therefore, we can see this FP is the perpendicular on this side AB. And now let's make an observation. We know this DE segment length is 4 units. So therefore, this AP segment length is going to be 4 units as well. And likewise, this EC segment is 5. So therefore, this PB segment is going to be 5 units as well. So therefore, we can see that this whole side AB is going to be 4 plus 5 is going to give us 9 units. And now let's assume that alpha and beta are our two complementary angles. In other words, the sum of these two angles, alpha plus beta, must be equal to 90 degrees. Now let's assume that this angle is our angle alpha. We know this whole angle is 90 degrees. So therefore, this angle has got to be our angle beta. Now let's focus on this triangle AFP. We know this angle is alpha. This is our 90 degree angle. So therefore, this angle has got to be our angle beta. And now let's focus on this other right triangle BFP. We know this angle is beta. This angle is 90 degrees. So therefore, this angle has got to be our angle alpha. So therefore, we can see that this triangle APF, we are talking about this triangle APF, and this other triangle AFB, we are talking about this whole big triangle AFB. Both of them are our similar triangles according to angle-angle similarity theorem. So therefore, we are going to have a proportion. So therefore, we can write down the ratio of this side AF and this side AP. So let me go ahead and write down AF divided by side length AP is going to be equal to the ratio of this side AB and this side AF. So therefore, I can write down AB divided by AF. Now we can see our this AF length is X. So I'm going to replace that one with X. Likewise, this AF I'm going to replace with X as well. And this AB side is 9. So I'm going to replace that one with 9. And finally, this AP segment length is 4 units. So I'm going to replace that one with 4. So therefore, we can write X divided by 4 equals to 9 divided by X. And now we are going to cross multiply. So therefore we are going to have x times x is going to give us x square equal to 4 times 9 is 36. I'm going to undo this square by taking a square root on both sides. So therefore our x value turns out to be positive 6 units. And we are going to ignore the negative value of x since our x represents the side length. So thus our x value turns out to be 6 unit. And now we are going to calculate the value of y as well. And here's our next step. Now we can see our this triangle BPF. We are talking about this triangle BPF. And this other triangle AFB. We are talking about this whole big triangle AFB. Both of these triangles are our similar triangles according to angle similarity theorem. So therefore we are going to have a proportion. So therefore we are going to have a ratio of BF and BP, and that is going to be equal to the ratio of A, B and BF. And now let's make an observation. We can see this BF is our y. So I'm going to replace that one with y. And likewise, this BF I'm going to replace with y as well. And this AB side length is simply 9. So therefore I'm going to replace that one with 9. And finally, this BP segment length is 5. So I'm going to replace that one with 5 over here. So therefore we are going to have a y divided by 5 equals to 9 divided by y. And we are going to cross multiply. So therefore we are going to have a y square equals to 45. I'm going to undo this square by taking square root on both sides. So therefore our y value is going to be equal to 3 times the square root of 5 units. So thus our y value turns out to be 3 times square root of 5, as you can see over here. And here's our final step. Now we are going to calculate the area of this yellow shaded triangle AFB. And now let's recall the area of a triangle formula once again. Area equals to a half times the base times the height. In our case, the base of this yellow triangle is 6 and the height of this triangle is 3 times the square root of 5. So therefore the area of this yellow shaded triangle is going to be equal to a half times the base is 6 times the height is 3 times the square root of 5. And if we simplify the right hand side, the area of this yellow shaded triangle turns out to be 9 times the square root of 5 square units. So thus the area of this yellow shaded triangle turns out to be 9 times square root of 5 square units. And that is going to be approximately equal to 20.12 square units as well. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.